On the back side, page 6, you'll notice I've selected a few problems that I want to go over with you. Cross out 19 and 20. We're not going to look at those, but let's go ahead and start with 11 and 13. I've taken the liberty of drawing my boxes in advance because what we have on these problems is, again, a binomial times a binomial. And when you have that, I'm going to suggest that you do the box method, the Punnett square. So here's my binomial across the top, and there's the binomial on the side. That is horrible. Let me see if I can make that line a little straighter. So I've got 8 plus I on the top, and then 8 minus I on the side. And it would have been okay if I switched them around and put the 8 minus I on the top. All right, let's multiply to get in the box. This becomes 64. This becomes a negative 8i. And this up here is a positive 8i. At the bottom, you're going to have negative I squared. Remember, when we simplify, the I squared becomes negative 1. And negative 1 times negative 1 is a positive 1. So this bottom box here is simply positive 1. This is 64. And 64 plus 1 is 65. Notice what happens with these two terms. They're like terms, but they're going to cancel out, which means your final answer ends up only being 65. For the next problem, you're going to write the same thing going across the top, and then, well, not actually the same thing, but it's 5 minus 4i and 5 plus 4i. Go ahead and multiply 25, 20i, negative 20i, and then negative 16i squared. Now, I'm hoping by now you know what's going to happen, because I want to make this neater. You know that this right here is going to make it a negative 1. And a negative times a negative makes positive. So this is going to end up being a positive 16. Positive 16 and a positive 25 is going to give me 41. These are going to cancel, and again, I'm left with simply one term. Now, this happens because these types of problems, these special types of problems are called complex conjugates. And basically what it just means is that you've got a number plus the imaginary, and then you got that same number minus that imaginary. So see how you have on number 12, 3 minus I, 3 plus I, negative 7 plus 2i, negative 7 minus 2i. The sign in the middle just changes whenever you have complex conjugates. The last section, we're going to look at quadratic equations that have complex solutions, not just imaginary, but complex solutions. Now, these look a little different than what we've been doing because you've got the parenthesis, but it's actually quite simple. All you need to do is remember that we're getting our parenthesis isolated. So that means I just want my parenthesis on this side. I don't want anything on the outside touching it. I don't want anything underneath it multiplying it. Nothing at all. So when you see that you've got your parentheses isolated, all you have to do is the opposite of taking it to the second power and find the square root. When you take the square root, you cross out the exponent. If I take the square root on one side, I have to take it on the other side. So now this is going to become x plus 2. The exponent is gone. Bring down your equal sign. Notice what you see here right off the bat. You see a negative 81. That negative becomes an I. And now you have a positive 81. Well, I can simplify this because I times the square root of 81 is just 9. So I've got 9i on this side. Notice on the other side, though, I got some more stuff going on. And I forgot to write my plus or minus. So let me insert that right quick. Because when you take the square root, it's always plus or minus. So it should be a plus or minus 9i. If I want to get the x by itself, this has to come over on that side. The only way to bring it over is to subtract it. So what I'm going to do, since this is a real number, is I'm going to put the real number first, -2, okay? Bring down your plus or minus sign, and then write your 9i. This is all you do. You're done. We're skipping number 16 because it's exactly like number 15. And I want to show you one where there's something on the outside of the parentheses. Whenever there's something on the outside of the parentheses, if it's touching the parentheses, all you have to do is divide by that number. Since this is a -1, it's an invisible 1, you're going to divide by -1 on both sides. Now this is gone, and I am left with x plus 4 in parentheses by itself. This will now be equal to -75. Now this problem looks exactly like number 15 above it. So when you're at the point where you have your parenthesis raised to a power, the opposite of raising it to the second power is taking the square root. Cross out your symbol, your exponent right here. And then when I take the square root on this side, immediately I'm going to put plus or minus so I don't forget. But then I have to take this negative sign and write it as an I, okay? Now, on this side, I got x plus 4, no longer in the parentheses, okay? The 75, though. 75 is not a perfect square, but it can be split. So I'm going to see what two things will give me 75. Well, it should be the square root of 25 times the square root of 3. All right, now keep in mind, there was an I, there was a plus and minus sign, there was an x plus 4. Simplify this portion right here, because this will now become 5i. So I've got plus or minus 5i. And whatever's in the radical, y'all, we're just going to leave that in there, okay? So the square root of 3. Oh, hold on, that's a little too thick. The square root of 3 is in the radical. Bring down your equal sign. Bring down your x plus 4. And I hope you see that the last step is to bring the 4 over. And the only way I can do that is by subtracting it. So when I do that, now I have x equals -4. Please put it first because it's the one that's the real number. And then you've got plus or minus 5i. And then the radical will remain the square root of 3. This is all I've got. You're done with that problem. And let's see, was there one more problem? Yes, number 18. Again, just like number 17, you have a number that's touching the parenthesis. When this happens, you want to get the parenthesis by itself by simply dividing. So I'm going to divide both sides by 2. Divide by 2 here, divide by 2 here, and now we cross out. You have your x minus 1 in parentheses. It's still squared, but this is going to be equal to -28 when I divide. Now I'm getting rid of that parenthesis with the exponent by taking the square root. Cross out this, and then when I take the square root here, immediately I want to put plus or minus, and I want to put an I because of this. But then I need to split the 28 because we know that 28 can be split into the square root of 4 times the square root of 7. Bring down everything else on this side. I don't want to skip any steps. Now let's simplify, because this portion here is going to become plus or minus 2i, because the square root of 4 is 2. Bring this down, and then look, I need to get this over here by adding it this time. So I'm going to have final answer x equals 1 and then plus or minus 2i times the square root of 7. See, I just kept bringing the square root of 7 down at each step.